What if I told you that the flap of a butterfly's wings in Brazil could set off a tornado in Texas? Sounds poetic, maybe even absurd. But this is not just a metaphor. It's the essence of chaos theory, one of the most mind-bending ideas in modern science. In today's journey, we're diving deep into chaos theory and the butterfly effect, where mathematics, physics, and philosophy collide to challenge everything we thought we knew about prediction, certainty, and reality itself. By the end of this video, you'll see how small changes in initial conditions, tiny, almost invisible shifts, can reshape the universe in ways we can't possibly imagine. Before we get too deep into this topic, be sure to like this video and subscribe to the channel. This helps to bring more valuable content to the platform for your knowledge and understanding. Remember, knowledge is power. Now back to the episode. Chaos theory doesn't mean disorder or randomness. Instead, it describes systems that are deterministic but unpredictable. What does that mean? Imagine you know all the rules of a system, say, how a pendulum swings. You can write the equations down, you can solve them, and you know exactly what will happen. But now add a second pendulum hanging off the first. Suddenly things get wild. That double pendulum dances in patterns so complex and sensitive that the tiniest nudge completely changes the outcome. That's chaos. Orderly rules producing unpredictable behavior. The phrase butterfly effect was coined by meteorologist Edward Lorenz in the 1960s. He was running computer models of the weather, and to save time, he rounded one of his inputs from 0.506127 to 0.506. That tiny difference, just 3 decimal places, led to a completely different weather forecast. Lorenz realized something staggering. Small changes in initial conditions can lead to vastly different outcomes. This became the foundation of chaos theory, and the poetic idea that a butterfly's wings could set off a tornado half a world away. But chaos isn't total disorder. Lorenz discovered something called a strange attractor, a hidden structure within chaos. Imagine plotting weather data in 3D. Instead of scattering everywhere, the points loop into beautiful, infinite butterfly-shaped patterns. This means chaos is not random. It's patterned, unpredictable in detail but organized in shape. It's like jazz improvisation. It feels wild, but it still follows hidden rhythms. Chaos isn't just about storms, it's everywhere. In biology, the heart's rhythm can slip into chaotic patterns, leading to arrhythmia. In astronomy, planetary orbits, seemingly steady, can wobble into chaos over millions of years. In economics, tiny shifts in markets can spiral into booms or crashes. Even in psychology, our thoughts and emotions can ripple into unpredictable cascades. Everywhere you look, the butterfly effect whispers, "Nothing is truly small." Here's the paradox. Chaos is both terrifying and beautiful. On one hand, it means we live in an unpredictable universe. We can't control every variable, and certainty slips through our fingers. But on the other hand, it means the future is open. The smallest action, the tiniest choice, could reshape reality in ways you can't foresee. Your life, your decisions, your voice, they ripple outward like butterfly wings. Chaos theory forces us to ask big questions. If the future is so sensitive, can we ever predict it? Are we the creators of our destiny, or just passengers in a storm? If every small action matters, does that give our lives more meaning, or make them terrifyingly fragile? Some philosophers argue chaos theory proves the limits of human knowledge. Others see it as proof of a universe that is alive, creative, and endlessly surprising. Of course, the butterfly effect has become a cultural icon. Science fiction movies explore how tiny changes in the past alter the future. Popular books use it as a metaphor for love, chance, and destiny. Even video games play with branching narratives where one small choice reshapes the whole story. It's both science and poetry, a bridge between mathematics and meaning. Now, here's where things get really interesting. Quantum mechanics already tells us the universe is unpredictable at its core. Particles don't behave with certainty, only probability. When chaos theory meets quantum physics, we enter a new frontier: quantum chaos. This explores how quantum systems can show chaotic-like behavior, adding yet another layer of mystery to our reality. Are we living in a universe where even uncertainty is uncertain? So, what can we take away from chaos theory and the butterfly effect? The universe is deterministic in rules, but unpredictable in outcomes. Tiny changes, so small they seem meaningless, can reshape the future. Chaos is everywhere, in weather, in our bodies, in our minds, in our cosmos. And most importantly, our actions, no matter how small, matter more than we think. Next time you hesitate over a choice, remember this: you might just be the butterfly flapping its wings, setting off a chain of events that echoes through time. If this journey through chaos theory and the butterfly effect blew your mind, imagine what else lies hidden in the fabric of reality. Hit that like button, share this with someone who loves science, and subscribe for more deep dives into the mysteries of the universe, because the next video might just be the butterfly wing that changes your perspective forever.